In this videotape, we're going to give you an overview of Java's inheritance mechanisms. In a separate videotape, we'll be going over Java's interface mechanism, which is related to its inheritance. So if you're looking for information, reading material on this, you can go to the Scott text and read Chapter 9. It has some good overall information on inheritance in different languages, Java, C#, C++, that's very useful. You can go and look at my kind of Cliff Notes like stuff on Java's inheritance system, and you can go and take a look at Oracle's tutorial on Java's interface and inheritance. We're actually going to be just working through a program example to show you Java's features of inheritance and how they differ from C++. So what I'm going to do is I'm going to start by creating a graphical object class, which you may remember from the inheritance hierarchy lecture was meant to be the top of the inheritance hierarchy. So just like in C++, you start with class graphical object, and we're going to create a few methods. Let's create one called public draw, so void draw with no parameters. And I could create an empty method body. You remember I wanted to create something that was virtual and that was going to be overridden by my subclasses, and specifically you may remember that I wanted this class to be pure virtual, meaning having no method body. The way I do that in Java is I declare my method to be abstract. And when I do that, I also have to declare my class to be abstract. So if a class contains one or more abstract methods, it itself must be declared abstract. And once I've declared something abstract, it by definition is virtual and is meant to be overridden by any of the subclasses. Also, once I declare it abstract, I cannot create a class of graphical object, which you can give it a try. You'll see that you get an error message. You'll notice here that I also declared it as public, so that puts it in the API for graphical object. You may remember that in C++ you can do something like this. You can say public colon, and then you can have a sequence of methods that you might declare, such as bool contains point, say int x, int y. You cannot do that in Java. Each class that you want to be public has to be individually declared public. So here I would have to say Boolean, and I would have to say public. And of course, if I do not declare it abstract, then I would have to declare some function body for it right here. Okay, so for the most part, you're going to either be declaring your methods to be public, or you're not going to give them any modifier at all. You may remember that in C++, if you want something to be protected from the outside world, you would say private, like say private int x, or you would say protected int y. You can do this in Java. They have somewhat different meanings than they do in C++, and until we get to Java's package mechanism, we can't really go further into it. For the time being, I suggest that you simply use either public or no access modifier. And what you really have here is something called package level protection, which means that everything that is in my package, and I know here I haven't declared a package, but normally it would mean that these variables are shared by all classes in the same package. Okay, so just quickly, you've seen me do things like import java.util. Java.util is a package. I might declare this to be, say, package graphics, and now any other class that was also part of this graphics package would have access to X and Y, which is typically what we want. We want to share our implementation among related classes. Okay, so the next thing we want to cover is constructors. So constructors look a lot like they do in C++, except that you may remember in C++ you can have the concept of an initializer list. So I could say like x3, y7, or more likely I might have these as parameters. Okay, and I might say, actually probably need something better than, we'll say x1, y1, and then we could say x1 and y1. And that is the C++ way. That is not the Java way. Java does not have initialization lists. So you would actually have to say here x equals x1, y equals y1. So no initialization lists in Java. Okay, and remember that you can define initialization blocks if you want. So I could have something here like, say, x equals 0, y equals 0. And this initialization block would get executed before the constructor gets called. However, in this case, if I was really looking to initialize stuff, remember you can just initialize it without having to do an initialization block. So you could simply have done it like that as well. Okay, so we've set up now an abstract class called graphical object. And now let's say we wanted to create a subclass, and I'm not going to create a box-like object like I did in the previous one. I'm just going to go directly with a rectangle. So you use the extends keyword in order to create a subclass. And if I want to, so I'll create a constructor. Let's say int left, int top, int width, and int height. And I probably need some variables. So, okay, int width and int height. And you may wonder, well, where's the left and top? Well, since I'm extending graphical object, I'm going to use its x and y variables. And in order to call the superclass constructor, I can do it by using super keyword, and that will call the superclass constructor. And this must be, the call to the constructor must be the first line of the program. So the call to the constructor should be, I'll say should be the first line, because if you don't, it's going to call a super constructor anyhow, and if you don't put it on the first line, it's going to call the zero argument constructor. And you can see graphical object does not have a zero argument constructor, so the Java compiler is going to complain. So you should put your super constructor call on the first line, or else Java is going to call the zero argument constructor for you. So now I could go ahead and say, now in this case I'd have to say this dot width equals width, and I'd have to say this dot height equals height. So the this is simply a reference to the current instance of rectangle that we're creating, and is automatically defined for us by the Java virtual machine, just like it is defined for us by the C++ compiler. Okay. And in general, let's say that I had defined another method up. Let's say we decide we're going to override contains point. Okay, so up here we had a method for contains point. Let's say we decide to override it. Not a problem. We can say public boolean contains point. And the interface has to exactly match the one above. So if we went above, you would see that it was also public boolean. We can't, for example, leave off the public. That would get us an error message from Java's compiler saying that it needs to be public. We also cannot change the return value. If I made this int, I would also get an error message from Java. So we'll just say contains point x and y. So we could either go ahead and do our own code here because we are overriding it. So we might say, for example, if x is greater than left and y is greater than top, and some other stuff. By the way, we're saying, I'm not going to get into it, but we could just start doing our implementation, or sometimes we need to get access to the superclass, this method. So we might, for some reason, decide to call the superclass, and the way we can do that is a super and then contains point and just pass it there. Now, this would be pretty silly to do this, because there's no reason in this case to override it. But I'm just trying to show you that if you, for some reason, want to access the superclasses method, you do a super and then dot and then the name of the method. Okay. So the other thing is, you may remember that we talked about virtual versus non-virtual methods in the previous lecture on inheritance. And by default in Java, all methods by default are virtual. Okay? So if we want them to be virtual, we don't have to do anything. But sometimes you may remember we wanted a method to be not virtual. So for example, we might have getX, and probably we don't want that to be a virtual method. We want that behavior to be inherited by all subclasses. So in that case, we would add the keyword final. And the keyword final says that the method is non-virtual, and its behavior must be inherited by the subclasses. Okay, and now a few final points about Java's classes. First of all, I want to show you an actual example of how virtual and non-virtual methods work. So I've created a file called animal.java, and it has a single method that is called print method. And you can see that it says print I am an animal. And then I have a class dog that extends animal, and you can see that I have overridden it to say I am a dog. And finally, I have a class cat that extends animal, and you can see that it accepts animal's implementation of the print message. So then I've created a main in animal and created 3 objects: an animal, a dog, and a cat. And what you're going to see is that when I print an animal, well, let's do it and see what happens. So I've already compiled it. You can see that the first print message right here, that it prints I am an animal, which makes sense because that's what the method does for animal. Then you can see for dog, it prints I am a dog down here. And the reason for that is that dog overrode the print message from animal. And finally, you see that when I print message for a cat, it prints out I am an animal. And the reason is that cat extends animal but does not override print message. Now, let's play around a little. Instead of having 3 of these, I'm just going to have 2. And let's see what happens if I make an animal be a dog. Remember from our lecture on inheritance that this is permissible because dog is a subclass of animal, and any place therefore where I use a animal, I can also use a dog. Okay, so now if I run it, or compile it, and I run it, I get I am a dog. And the reason is because since print message is a virtual function, it waits until runtime to determine which version of print message to use, and since A is currently a dog, it uses the method associated with dog. And just to show you what happens, let's say that I have if I try to use another method of dog, let's say I have public void print dog system.out.println I bark. And let's say that I up here try to call that. So I say a.printDog because I know it's a dog. And let's give that a whirl. And you see that I get an error message, a.printDog, method printDog cannot find symbol. And the reason is it says variable a of type animal. And sure enough, because we have animal does not support the print dog method, it is an error. So basically, when you assign a subclass to a superclass object or variable like I did there, you're only allowed to use the methods now of the superclass. The final thing that I want to do is show you the order in which superclass or constructors get called in an inheritance hierarchy. Let's say that I had something like graphical object and a box object and a rectangle. And remember that no matter what happens, when I create an instance of rectangle, the constructor for rectangle will call some constructor on its superclass. So the order is that of constructors that get executed is the very top one gets executed first. So what will happen is the constructor for rectangle will call the one for box object, but it will immediately call the one for graphical object. So it's always the case that the first constructor that gets executed is the constructor at the top of the inheritance hierarchy. In fact, above this, remember, there is object. However, object does not have, it has a constructor that does nothing. So effectively, the first one that gets called is graphical objects constructor, then box objects constructor, and then rectangles constructor. So that is the order of constructor calls, and it goes top to bottom. That concludes our discussion of Java's inheritance mechanisms. We'll talk about its interface mechanisms in a separate video.